It's me again, your favorite video presenter. Yes, so guys, today we're going to talk about special parallelograms and the properties of those special parallelograms. Now, let's think for a second. If I say that they're special parallelograms, that means that they are still parallelograms, but there's more specific properties that they're going to have. For instance, the first shape on your note says a rhombus. Well, guys, a rhombus is a parallelogram, just like this, but it has to have 4 congruent sides. Notice my little rubber bands here represent the diagonals, right? I'll put it right on my nose, okay? So the diagonals still bisect each other, but check this out. I want you guys to watch right here, this angle right here, where these diagonals intersect. I want you to watch the measurement of that angle. Notice, oh, let me move it this way. Notice if I move this rhombus, the angle does not change. That's because in a rhombus, when you have 4 congruent sides, your diagonals are going to intersect at 90 degrees. They're going to be perpendicular to each other. Okay. Now, the second shape on your notes says that you have a rectangle. Well, a rectangle is also a parallelogram, right? Here we start with a parallelogram. But what's special about a rectangle is that it has 4 right angles, which means that it looks more like this. Now, I want to talk to you guys for just a second. As I put the diagonals right on my nose, okay, I want you guys to notice what happens to the diagonals here. So in a rectangle, the diagonals do not intersect at 90 degrees. But, guys, what do you think might be true about the length of the diagonal? So notice if it's a parallelogram, one diagonal is longer than the other. But in a rectangle, what do you guys see? I see that the diagonals are congruent. Okay, so the diagonals are going to be the exact same length in a rectangle. And remember, a rectangle has 4 congruent angles. Now, the next shape that it talks about is a square. So, guys, a square is a parallelogram that has 4 congruent sides, which makes it also a rhombus. But what makes it a square is that it has 4 right angles. So not only does it have 4 congruent sides, but it has 4 right angles. Now, if you guys notice, and I know I'm looking kind of weird here, okay, the diagonals in this guy right here, when you go from a rhombus to a square, they're still going to be perpendicular. And also, guys, in a square, the diagonals are also going to be congruent. So in a rhombus, they're not congruent, but in a square, they are congruent. The diagonals are congruent. Okay, so those are some special parallelograms, okay? The diagonals still bisect each other in all of them because that's a property of a parallelogram. The opposite sides are still congruent and parallel. That is a property of a parallelogram. The opposite angles are still congruent, okay? And, okay, the adjacent angles or consecutive angles are supplementary. Now, we're going to explore something very special about opposite angles in a rhombus and in a square here in just a second. As a matter of fact, I want you guys to go down to number 5, and we're going to look at that. Go down to number 5. Okay, so down here at number 5, notice it says here that the quadrilateral is a rhombus. So that means that I know that it has 4 congruent sides. But this is saying to mark all the congruent angles. Well, guys, let's look at our flip chart. Okay, and our flip chart tells us a little bit something more about what the diagonals do to those opposite angles. So remember, we just said that opposite angles have to be congruent. So that means that this whole angle is going to be congruent to this whole angle. But in a rhombus, the diagonals bisect the opposite angles. So that means that angles 1, 5, and 4 and the 51 degrees are all congruent. They're all the same. So if that's the case, then what is the measurement of angles 1, 4, and 5? Okay, so let's see. If angle 1 is congruent to 51, then it has to be 51 degrees. Same thing with angles 4 and angles 5. Those are all 51 degrees. So I'm going to label those 51, 51, 51. Okay, now it's also true about the other opposite angles are congruent And according to our flip chart, those angles are also bisected. So that means that right here, these are congruent, these are congruent. Oh, so that means that angles 2, 3, 6, and 7 are all the same. But we don't know any of those measurements yet. Okay, but do you guys remember what I showed you with my little box? The diagonals in a rhombus intersect at what kind of angle? What is that angle measure that they intersect at? Hopefully you remembered or you looked on your notes or your flip charts. The diagonals intersect at a 90-degree angle. The diagonals are perpendicular. Okay, well then, hey, we know the measurements of 8, 9, and 10 are all 90 degrees. But how does that help us to find, like, let's just say the measurement of angle 7? Well, check this out, y'all. Okay, we're going to look at just this triangle right here. And that's going to help us to find the measurement of angle 7. Okay, so I'm going to redraw it out here. Okay, and let's see here. We know that this angle is 90. This angle up here is 51. And this is our angle 7. That's what we need. Okay, well, guys, you've done this before in a triangle. Remember, all three angles in a triangle add up to 180. Okay, so you guys solve it and tell me, what do you get for x, which is also the measurement of angle 7? What do you get? Okay, so hopefully, you know, your brains are kicking in and you're saying, hey, Miss Smith, we got 39 degrees. And there in the box, right there in the red little box, is how I figured that out. Well, wait a minute. If angle 7 is 39 degrees, then that means that angles 2, 3, and 6 are also 39 degrees. Okay, so now notice, guys, what we did here is we used the properties of angle measures in a rhombus to solve for this problem. And if I go back and look at the original picture, hey guys, notice there was only one angle measurement that was given to you, just one, and we were able to find all of the rest of them. Okay, pretty cool, huh? I think so, but y'all know I'm a math geek. All right, let's go down. And now, hey guys, let's look at rectangles, a property of a rectangle. Let's go look at number 10 together. I'll meet you down there. Okay, so down here at number 10, notice that we don't have a picture. So we need to read the instructions carefully. Okay, it says to find the lengths of the diagonal of the rectangle PQRS. Okay, so we're looking at just number 10. Now, guys, I'm going to ask you, do you remember what is true about the length of diagonals in a rectangle? Okay, so hopefully you either referred to your flip chart or your notes and you said, hey, Miss Smith, the diagonals in a rectangle are congruent. So it gives you, here's one of the diagonals, here's the other diagonal, which means that if they're congruent, then we set those expressions equal to each other. Okay, well guys, go ahead. I want you to go through and I want you to solve for x. And first, I want you to tell me, what do you get for x? Go give it a try. Okay, so how'd you guys do? Okay, you're solving for x and you get that x is 0.5. Now, if you did not get 0.5, look at my work on the screen, compare it to what you have, and then see where did you kind of make a mistake, okay? So look at that. Now, 0.5 is not our final answer, is it? Okay, so our final answer, it's asking what is the length of each of the diagonals. So now we need to go plug x in to each of those expressions and get the lengths. So why don't you guys go do that? Plug x in and tell me, what do you get for the length of SQ and RP? Okie dokie, Smokey. So you should plug in x and you can put that straight into your calculator just like I did over here and get that each of those diagonals is the length of 4, which is what it should be because remember, diagonals in a rectangle are congruent. Okay, congratulations, guys. Okay, so let's go and guys, I'll talk to you guys about number 20. Number 20 is a longer problem, but you're going to do it on your own, but I'm going to talk to you guys about it and how to work it out. All right, I'll see you guys down at number 20. Okay, so we're down here at number 20. Now, like I said, I'm not going to work this out with you. You're going to work this out on your own. But I want to talk about what this says. On this part, it says find the slopes and the side lengths of the quadrilateral. So just remember, little m, that says the slope of jk. So you're going to use points j and k. You're going to plug it into the slope formula. Okay, you're going to find the slopes of all 4 sides. Now, why do you need to do this? Well, guys, let me remind you. You can use the slopes of a line to determine whether or not you have perpendicular lines. Remember, rectangles have perpendicular lines. Squares have perpendicular lines. So you need to see, are any of your slopes negative reciprocals? Okay, so that's why you're finding the slopes. Now, the second thing it says is to find the side lengths. Okay, guys, remember, the lengths of the sides, okay, you would use the distance formula. And the reason you're going to find the lengths of the sides is because, let's think about this. If all 4 sides are congruent, then it could be a rhombus, or it could be a square, okay? So you want to see if any of the lengths are the same, okay? If they have the same lengths, okay? If you only have 2 lengths that are the same to each other, then equal to each other, then that's probably a rectangle. So this is why you're going to use this, because on the second part of number 20, okay, which is right here, you are going to determine, do you have a rectangle? Is it a rhombus? Is it a square? Is it all 3 of them? And you have to say why. How do you know that it's a rectangle? And you're going to base that off of the information that you get from working out the slopes and the side lengths. Okay? Now, guys, rectangles, rhombi, and squares, again, they are special parallelograms, so they're still going to have all of the characteristics of a parallelogram, okay, and they're going to have some of their own. Well, guess what, guys? That's it. So, in class, we'll see you soon. Adios!